Compound interest is interest computed on an original amount, a loan or an investment, as well as any accumulated interest from previous years. There is a formula, an exponential function, that can be used to calculate the future amount of a sum of money that earns interest. So the future amount accumulated, A, of a principal or present value, P, invested at an interest rate of R after T years, is given by A equals P times 1 plus R over N to the NT power, where again, A is the future amount, P is the present value or the principal, R is your interest rate, T is the time in years, and N represents the number of compoundings per year. Some vocabulary that you should be familiar with concerning N is annual compounding, that's once per year, semi-annual compounding, that's twice per year, quarterly compounding, 4 times per year, monthly compounding, 12 times per year, and daily compounding, 365 days per year. Compounding refers to the number of times that interest is going to be calculated and added on to the present value. So if you have quarterly compounding, that means 4 times each year, interest will be calculated and added on to the amount. Some banks may also use continuous compounding interest. With this kind of interest, interest is compounded every moment of every day. When this type of compounding happens, we need another formula other than the one that we already have. The continuous compounding interest formula uses the number E. The future accumulated amount A of a principal P continuously compounded at a rate R for T years is given by A equals P E to the RT power. These two formulas together will give you the future amount of any compounded interest situation. Example number 2, you wish to invest in inheritance of $8,000 into a money market account for 6 years. Should you choose the account that pays 7% quarterly or 6.9% monthly? So we're going to do basically 2 calculations for both of these. The present value that we're starting with is $8,000. And it says we're going to invest for 6 years. The difference on this one is we're going to have one situation with 7% interest compounded quarterly, quarterly meaning 4 times per year, and a separate situation where we will have 6.9% interest compounded monthly, being 12 times per year. So using our compound interest formula, we would have A equals 8,000 times 1 plus 7% in decimal format is 0.07 over 4 to the 4 times 6 power. Okay, so on your calculator, we would have 8,000 in parentheses 1 plus 0.07 divided by 4 raised to the, in order to get this correct, you either have to do 4 times 6 is 24 in your head, or you have to use parentheses around 4 times 6. If you have a TI-84 plus and you're actually typing in the exponent rather than having the caret key, then you could just type 4 times 6. But TI-83, or if you don't have the math print, then you'll have to use parentheses like I'm showing. Okay, and we get $12,131.54. Our other situation is if we have 6.9% interest compounded monthly. So using our formula, A equals 8,000 times 1 plus, in decimal format, 0.069 divided by 12, raised to the 12 times 6 power. So on your calculator, you would have 8,000 times, in parentheses, 1 plus 0.069 divided by 12 raised to the 12 times 6 power. And that gives us $12,088.52. So in this case, we would want to use the 7% interest compounded quarterly. Example number 3. Suppose the state government borrows $120 million in the form of bonds to complete a new bridge construction. The new bridge will be paid for using tolls, and the bond will not begin to be paid off until tolls are collected when the bridge is completed in 3 years. How much will be owed in 3 years if the bond pays 4.75% interest compounded continuously? So here our present value is $120 million. And we're told that time will be 3 years. And we're compounding continuously at a rate of 4.75%. Since it says compounded continuously, we're going to use our second formula of A equals PE to the RT. You should only use the other formula if you see things like compounded annually, semi-annually, quarterly, monthly, or daily. If you ever see compounded continuously, you are to use this formula. So putting in our values, 120 million, we can just use 120. Remember that your answer will be in millions though, times E to the 0.0475 times 3 power. So on your calculator, 120 times, again, your E button is here, second, and then your E button, 0.0475 times 3 power. And that gives us 138.378 million. So meaning 138,378,000.